chart here. Okay, let's see if, boom, boom, boom. Yeah, okay. Auto-saving is working. 40 is not valid, but that's okay. Oh, well that sucks. But, hey, whatever, if you're still getting paid, that's a good thing. So, alright, so there is a color chart. So I've just been playing around with this. I just learned how to do this stuff last night, so it's very fresh. So, and I definitely want to modify this code and get it working. And that's why I was like, let me live stream. Okay, so there is a website that I'm going off of that I found to be really, really good last night. And let me see if I can find it. It was. Well, it was in it. Let me see if I can search for it. Atari 2600 tutorial. There we go. Not that. It was this one. It was Atari 2600 programming for newbies. And the website that I used to start is this 8-bit workshop site that was pretty cool, actually. You can copy and paste your code or write your code directly in this window, and it'll automatically run it. And while that is, that was cool to start, and especially getting going, I thought it was cool. But the problem is it doesn't scale well for me because of, I am a professional developer. I need tools. I need things that will work better. Now, another problem I had was the slowness of it. I'd be typing along, and you make some instructions, and it automatically does stuff, and it can slow things down. And it was really frustrating because it's like I'm not wanting it to run it immediately. I want to actually, spend some time massaging the code and stuff and then run it. It is nice to have an automatic, development and all that, and that's great. The problem I see is that it gets really distracting. Because it's like complaining at you already about code, and it's like, I'm not done yet. Shut up. I'm working. And so I messed with this, and it was kind of neat, but then I'm like, I need a way to shut this off. Couldn't find a way to shut it off. So I'm like, you know what? Let me just mess with the emulators directly and get an editor working. Another issue that I had is the fact that a lot of the code that I was looking at in this here was, the spacing was really bad, and as a programmer, I'm really picky about my source code as far as how it looks. I can find and have the one up that I was using last night, but the issue is that things like having an editor to be able to easily do things like formatting is critical, and it's one of those things that the web-based editor is just not going to have it, and I know that, and it makes it a lot easier this way if I can just save off my work and be able to just do the development the quote-unquote right way. I would like to use, I picked Sublime Text because I've used it in the past, and it's my go-to text editor when I need just a standard text editor that it's not language specific. I am definitely on board with using the WebStorm and PyCharm and all the IntelliJ products. Great products, but they don't have arcane languages support, things like assembly and all that. And interestingly enough, I was expecting to see maybe some color code stuff for Sublime for Atari 2600 development, and I didn't see any. So I was like, well, that's interesting. So that might be something I might want to delve into, is how to make all of this stuff look good and colored and all that stuff. Could use VI, but I prefer having a window-based thing. Could use GVim or whatever, but I'm kind of over that. So So what I want to do right now is show the colors. Now this is going to be an interesting thing to be able to say, to figure out where I was, since I went through about 13 or so of these sessions, and at this point, I can go through it again, but I need, like, there's a color code thing in here, and I need to find what it was here. Guess I have to go through and this is all, this is just on the page. That's not useful. I want to see all the different pages. So scrolling through this is going to be a pain. At the bottom has a link. Links. That's what I need. I got up to Playfield Basics. Okay. Colorful colors. What the heck? Let's see what I think it said. It did. Okay. Colorful colors. So here's the colors, the thing that I wanted, and this is actually a very good image. I am going to save this image because I'm going to need that. I know that. So I'm going to, I might as well store it in the Atari 2600 directory. Oh, I have my old Atari 800 code. Interesting. Oh no, that's just Atari 800 emulator. I'm gonna put colors dot. Oh no, I don't want a web page. Yuck. No. What? Isn't this just an image? Okay. Guess not. There's some. Okay, I'll do it the old school way. All I need is NTSC. I don't care about the other countries. Sorry. If you live in one of those other countries, rock on. But I am not going to mess with that. So I am going to, let's see, put it in the desktop. And I'm going to put this on the screen just so that it's a reference. God, it's huge. And of course, the thing doesn't work right. Okay. So yeah, so what I'm doing here, and this is obviously, if you are interested in this development, go through the tutorials. There's a lot of good information on there, and I'm still doing it, and eventually once I get past this point of having fun with this, I will go back through and learn some stuff, more stuff, and then show you what I've got, and we'll see how this goes. So the idea is that the Atari 2600 is very, very, very simple machine. We have to do everything, and that's okay. If you know how it works and how you can do the things, then you can make it conform to whatever you're trying to do. Well, I guess I can check that off. The setup, the flow of the emulator. I'd like it to show up in a specific spot, but I think that's maybe too much to ask. Anyway, so at the beginning, it had a program basically to be able to cycle through colors, and that's cool, and it showed basically the basic ideas. But what I want to do, and right now I'm just playing around with background colors. But the idea is we do things in stripes to start, at least, and where I'm at in my learning. So I've done assembly language programming before, and so it's not totally foreign to me. If it is for you, follow along, ask questions if you ask, and maybe I'll know the question. But the basic idea is that we have to go. Everything is going from top to bottom on the screen, and if we want to change the colors, what I'm doing is, if you look at the way this is set up, the screen is this big. Well, the actual like time that the clock cycles is working is more like a screen that's like this big. You know, it's a lot bigger than the screen itself, and so you do work over here, and then you set it up so the line does something. Do work over here, does the line does something. And so what we have to do is we have to take into account every line that we're going through, and that's where we have all these different sections of the code. And I'm not, you know, I'll go into some of this stuff in a bit, but so basically we have a vertical blank, vertical sync, and you know, this is the stuff above the page, above the screen. This is the meat and potatoes, this main picture area. So and the way I've got it is, you know, really inefficient code, and I know that, and I'm working on that, and you know, I just remember, you know, found out how to do loops again in 6502. Not a problem. So, but for right now, what I'm playing around with is to change the colors so that it will, you know, print, you know, maybe a different color band. Not just a go through all the colors and all that. What I'm trying to do here is get a little bit of a handle on the colors. You know, I could do, you know, it'd be an interesting project is to just make like the American flag or something. You know, it's like that's a stripy thing. You know, I don't know how to make. I do actually know how to make a square. So that's interesting. That's a very interesting project. So let's try doing stars and stripes. And I admit I don't know how many stripes we have. So to the Googles, American flag number of stripes. 50 stars. Yeah, I knew that. 13 stripes. So this is, I want to make sure I use the current one. Not that one. 7, so it's 13. 1, 2, 3, 4, 5, 6, 7. So there's 7 stripes of red and 1, 2, 3, 4, 5, 6. Yeah, 6 stripes of white. Okay. So we have, so that's a good start. Let's try doing the red and white stripes. So we said 7, so there's 13 total stripes. So it's a nice odd number, which I say that facetiously. So we have, I'm going to use this one, chance to do this. Okay. So we have 13 stripes. And we have 7 red, 6 white. Okay, not a problem. So we have 192 lines. So basically vertical resolution. So 192. So if we divide that by 13, 192 divided by 13, about a calculator, and this would be a good thing to have online. And if Rayo is telling me, he'd be like, "Yeah, just use the command line." Yeah, well, I'm not that great at using the command line for calculator stuff. Okay, 192 divided by 13. It's going to be an odd number. Yep. Okay, so equals 14.769, etc. Now there is something at the bottom called an overscan, which they say don't use the overscan because TVs aren't able to see it. And for right now, until I know better, I think I want to stay within the 192. One of the things I was considering is using some of the overscan for the red, you know, for the bottom stripe. But I think I want to stick within the 192. So the issue is that we've got a round or a odd number of stripes. So that equals a odd number of lines. So if we did 14 lines per color, per color, so let's go, 13, 14 lines. So 14 times 13 equals 182 lines. So that means we have 10 lines left over. So that means we should probably put a border of 5 lines, and we can just do black. 5 on the top, 5 on the bottom. So what I'm gonna so that means what we're gonna do is we're gonna do 5 lines of black, and we're gonna do 14 lines of red, and then 14 lines of white, and then go straight down, and then we're going to do 5 lines of black at the bottom. Pretty straightforward. So the code that I have is really not efficient. It's doing repeats, which repeat is a macro that will just say, you put this all in the code. Like, just take all these lines and just repeat it that many times instead of using a loop. For now, I'm probably just going to say I want to just use the repeats to make it simple. And then after I get done, then I want to modify it and refactor it so that it'll use the proper loops. So for now, what we want to do is in the main picture, we're going to do 5 lines of black. So that's just 0, 0. And so what we're going to do is we're going to store. So at the beginning, we actually have black already in the X register. So this means we have X or 0 in the X register, which we need, we can use right now. We don't have to set it. The reason I'd want to set it is so that it will. It's interesting. So vertical blank, we don't have to do that every time. That's odd. We just start a frame. Oh, I think that start is something I wrote. Yeah, that's the start as I wrote, so I'm not using that right now. So what we do is we go through this process, all this lines of code, and then we do the end of screen stuff with the overscan. I still need to know what this is. I'm not exactly sure why this is here. And then we're going to go to the starter frame, which is up here. So, and it's just basically, it's when the program starts, it does this stuff at the beginning. This stuff is to tell the compiler that, this is a 2600 program or a 6502 program, and, where it's going to be in memory and stuff like that. So, this clears out the registers, so it makes sure that it's, everything starts at 0. When you start with the 2600, you have no idea what it's going to be. So this is a way of clearing everything out. It's a good thing. Starter frame, as I was saying, it does the stuff on the top here, the vertical blank. I'm not messing with this stuff really right now. The vertical blank, the vertical sync, all that stuff, I don't care. God, that looks bad. I need to fix that up. But the main thing is right here. So what I'm going to do is I'm going to, just for funds, I'm going to say, I need to fix tabs because that's crazy. I think it's automatically doing a tab thing based on the previous line, which is not really what I want. And I also want tabs. I might consider using tabs here. Fine, I'll move it, I guess. So what we're going to do is we're going to load in X. We're going to load 0 into the X register. So the way assembly language works is we have. I don't know if anyone's actually watching me right now. If you're watching, please be sure to say something just so I can see that people are doing or actually paying attention or not. Where is my window for YouTube? Yeah, right here. Okay. Concurrent viewers, 3. Yay. Ooh, someone likes me. Cool. All right. So, okay, so we're using an X register, and we're going to put 0 in that X register. Basically, think of a register as just kind of like it's a storage place for something, and everything in assembly uses registers. So we're going to put 0 in there, and then basically what we're going to do is we're going to put whatever's in LDX into the Colu BK, which stands for color, luminance, and background. I'm only playing around with background right now. I'm not actually sure how to do the others right now, but for now, again, I'm just learning as we go, and gonna show it. So I'm gonna store. So we're gonna store one line, and we're gonna put WSync into the A register. What that means is so WSync is you're waiting for what I understand, it's waiting till it gets to the end of the line, or the beginning of the next line. So what we're doing is we're setting the color, and basically it will draw this line until it gets to the next line. So the idea here is that we're going to do 5 of these. And so what I could do is the naive way would be to just do this. Oh, God, these tabs are going to kill me. It looks like from the way it works in DASM is if you put stuff in the furthest left column, it will treat it like a identifier. But so all your commands have to be indented. That seems to be the only requirement. These indents, I believe, are optional. But what we could do is we could easily say we're gonna put these 5 in here, and do this 5 times, which is a little silly because we know we're gonna want 5 times of these. So we can do a loop, or we can do a repeat. For now, I think I'm just going to do a repeat because it's going to kill me. How to turn off tab indenting, auto indenting. Okay, Sublime Text, turn off auto indent. Auto indent true. Okay, so it looks like all I need to do is go in here, go into preferences, settings. So I should be able to put it on here and say auto indent is false. And that hopefully will take my stuff into account. I need to comma. Alright, so we don't need this window anymore. So let's see if, aha, that's what I want. Okay, cool. So let's do a repeat. And we only need to do it on, so we only actually need to repeat the storing of the color block into WSync. We don't, what's interesting, I don't think I have to actually store it every time. That's using if you don't store it, I think it will use what it had before. Okay, man, take care. Thanks for joining. I'll see you later. I'll probably still be here, maybe. Okay. So my thought here is that we don't actually need to keep storing 0 in the background, because it'll still be 0. So what we should have to do is we only should have to repeat the waiting for the WSync. So let's try that. So let's do a repeat. We're going to do this 5 times. And so we're going to move this up here. I'm going to put a comment here. Display. Start. Bless me. Okay. So I'm gonna say we're gonna store. Thank you. We're gonna store the black once, and then we're gonna repeat 5 times. So we use a repeat rep end, and so theoretically, that should be our 5 lines. Now, one of the things you have to keep in mind is that when you're doing the display, the lines, you have to equal the right amount. Otherwise, you will get it will roll. And because right now, we're going to have 5 extra lines in here. So my thought, and to verify, I want to try compiling it and see what happens, because I believe that it will roll. And it's not rolling. So it's possible that I have to do my I have to do the storing the color block. Maybe not. I don't know. We'll see. Well, in any case, we have our 5 lines. Now we need to do our 14 lines of red. So what I'm going to do is I'm going to put a comment on here, black lines, border, black border, 5 lines. And then we're going to do a red stripe, 14 lines. Right? That's what we said? Yeah. So to do that, we want to pick a color that looks good. And looking at our color codes over here, I'm going to say this is probably a nice looking color. So I believe that's going to be 34 in hex. So let's try that out. Let's try 34. And we're going to store that into the background, and we're going to repeat that 14 times, and we're going to wait for the WSync every time, and repeat. And again, we'll be doing it in a loop, with the proper loop eventually. So I'm going to try seeing if this rolls. I could be totally wrong here. Interesting. Okay. It's not doing what I thought it would. Okay. So let's put the storing of the value. Editor's messing with me here. I'll get it down. Let's put the storing of the value in the loop, so that it does that as well. Okay, let's try that out. Oops, that's not what I wanted. We're gonna do that, and we're gonna do that. Okay, no change. Huh. Well, I'm not quite sure, because I mean, it's possible that this is well, 35. This is maybe the quote unquote red that I'm thinking it should be. Um, let's try. Um, let's try doing the white, and then we'll see what's going on here. So I'm going to do a white stripe. Cue white stripes music. Okay. White stripe 14 as well. So white is interesting. So it looks like 0E is white, or that's the thing. It goes in hex, but I think 0E and 0F are the same color. So let's try 0E. Yeah, let's see how that looks. Okay, let's do that. Oh, weird. Okay. First of all, why is it wider? It's bigger for some reason. It shouldn't be any bigger. That doesn't make any sense. So why did it choose green? Did I don't know, sure. Well, you see it first, folks. Okay. So I'm going to try 30 instead of the 34, which shouldn't matter. Okay, so now we get a darker green. Why? I know 30. I thought 30. It's 40 and 30 and 40 and 30. Yeah, I was doing 30 and 0, which should be red and black. It's a nice color green. The white's correct, but the red is not. I'm wondering if maybe it's something to do with more lines. I don't honestly know, but let's just do this. I'm going to do a brute force method. I'm going to put the red stripe, white stripe, and do this in a pattern. So I'm going to do this. That might be enough. I'm not sure. I need to count. So we've got red. No, we got the black border. Red, white, red, white, red, white, red. So 1, 2, 3, 4, and we need 7 red. So let's do this a couple more times. 1, 2, 3. That's probably enough. Okay, so let's remove the other stripes because we don't need those. And it's quite possible I just screwed something up too. All right, so let's verify that's the right amount. Oh, my iPad is complaining about power. Do I have a power cable handy? I do. Will this reach? Yes, it will. Okay, I've got the power. Okay. So let's try compiling this and running it. Ah, okay. So my guess is that it was something to do with having too many lines. So interestingly, so one of the things that's interesting about the emulator will show everything. And a TV wouldn't show this. So I know exactly what the problem is right now. The problem is, so we've got our black border, which is cool, and we've got red, white, and that's actually 1, 2, 3, 4, 5, 6, 7. So we actually have the right number of stripes. The top one is not actually a stripe. That's actually in the overscan, or they're in the top portion. So what we need to do is we need to make sure, since we've got over here at the end, we've got LDX 30. So because it ends in, we also did not do our stripe at the end. This will actually fix our issue. Because the problem is that we're ending in red and it's continuing on until the next one. So notice we've got, so there's vertical blank, which is there, but it's not being stored into the background. So what I want to do is I want to put this background, we need this background down here, the border down here. So let's do this. Now, if I'm correct, this will be all good. So let's see what happens. Yep. Okay. Again, you have to realize that the emulator shows everything, and not much you can do about that. I think there might be a way in Stella to tell it to not show the overscan. I'm actually kind of curious. It's good to know what it's doing. Stella, don't show overscan. Does Stella have an option to hide the overscan areas? Okay. Why does it? Yeah. Basically, it's not. Let's see. Basically, it doesn't look like it's a thing. Or it's dependent on your TV set. Yeah, but there's 192 lines. Only show 192 scan lines. You don't need to limit yourself to 192 in set display. Yeah, but if you wanted to work on a TV, you want to continue that. I mean, I guess we'll just ignore it. It just looks weird to me to have it be have the really big black bar at the top and the bottom. But that's normal. If you play, I think, a lot of games on here, it'll just do that. But whatever. Regardless, the cool thing is that I actually have a code the way I want it. It's doing a red and black, red and white, red and white, red and white. It's doing it not ideally. So let's see if we maybe can use a loop to do this instead. There's a couple different ways of doing this. The basic way that I'm thinking of here is that we have a loop for each line. Now, we can definitely eventually use some code to clean that up a little bit. What I'm hoping is that, well, I know we can do it. We can do a subroutine eventually to where it's like, we need a red stripe, we need a white stripe, we need a red stripe, we need a white stripe, and then having it be a lot simpler. But for right now, I think what I want to do is I want to do a simple loop. So to do the loop, what we're going to need is we're going to need a counter. So if we look up here, we're using this is a loop here, setting a variable to a certain number. If you don't specify a number, then it sets it to 0. I think that's how it works. Okay. But, so the idea is that we set it to a variable, and basically, so to go through this code here at the top, this is resetting everything. There's certain areas in memory that are for the TIA, which is um, it's a television interface. Basically, it's the workhorse on the 2600. Um, and then there's the RAM. So there's the CPU and there's the TIA, which is a separate chip for doing the graphics. Um, so what we want to do though is we want to clear it all out. If we do not do this, it's going to be, you could have random graphics in there. So what we're doing is setting it up so that we're going to just go through and set LDX to 0 and LDA to 0. So there's 3 registers on a 6502. There's the A, which is the accumulator, and then there's the X and the Y, which are index registers, is what they're called. And you can't just add to the accumulator, which sounds kind of like it shouldn't be named that, but whatever. So what we're doing here is the line 14 is it's taking whatever's in X, storing it in A. Actually, no, I take that back. What it's doing is it's taking 0 and putting it in what's in the X, or putting it in the X register. Rather, it's using it's I'm explaining this badly. It's using I think it's called indirect addressing mode. Basically, what it's doing is it's like a pointer in that it's saying LDX is pointing at 0, so it's saying store 0 at whatever X is pointing at. If that makes any sense. So we've got 0 as the beginning, so it's pointing at 0. It's putting 0 into the 0th memory location, and then incrementing X so that it's going to the first 0 and it goes to 1. So then it's copying 0 into the 1 memory location, and 2 and 3 and 4 and 5. And so the idea, though, is that you're going through, and this is using a trick that seems to be a widespread thing, is the fact that this is an 8-bit register, or 8-bit machine. And what it's doing is it's going from 0 to FF, and then when it hits 0 again, that's when it's flipped. It's once it goes from F, or it goes once you get up to F, it goes FA, FB, FC, FD, FE, FF. Then it rolls over to 0. So the idea is clear is set to 0 because it's a label that's set to 0 because we haven't set anything. That's fine. But what it's doing is it's saying branch not equal clear. So what it does is it goes back to clear. But it's using a trick basically. But if we look down here, the vertical blank is saying it's this another loop here. It's saying store or store into the A the W sync. Okay, fine. Or store whatever's in A, I should say, into W sync. And then we're incrementing X, and then we're doing it again. So, and it's comparing to see if X is equal to 37, and if it is not, so that's the branch not equal bit. This didn't need this is a trick. Normally you would need a branch, or rather a comparator in there to say, compare it with some number. And that's what we're going to need. What we're going to need to do in our loop is we're going to need to have a number that we're wanting to use, like A, and then we're wanting to use X as a looping register. So to do that, what we're going to do is instead of using X, we're we're going to want, so A is going to be equal to 0. And this is going to be this is going to be tricky. I guess because we're going to need actually a third one, because we need one value to go into the background, which is our current color. Then we're going to need the another value, which is A, which is going to be 0 coming into this. Is oh, interesting. WSync, it does not matter what you put in it. You have to store something in it. But the act of storing anything in it, according to the docs that I was reading, will work. So as far as I know, we could actually use STX here, and it would be fine. Let's try it. So what we're going to do is we're going to set, to do a loop, we're going to have to do a variable. So I'm going to call it, I'm just going to call it black. And then what we need to do is we need to, now why is it on one line? I'm actually not quite sure. I'm going to say we're going to go to black, and we're going to do LDX. We don't want LDX there. What we want is, because it's going to use an instruction, we don't need that. What we want is outside of black. What we're going to do is we're going to take X. Oh, I didn't check that. Ooh, I need to do that. Before I do this, let's back this off. There was something I needed to test, and that was, and this is a good test here. Do we have to store this black, or the black on here, or storing it into the color background? My contention is that we do not. So I'm gonna put it there and see what happens. So let's go with that. Let's go with that. And it still has the same effect. Okay, that's a good sign. Another thing I'm going to try is I'm going to try storing whatever's in X. That should still work. We don't need to use another register, is my point here. Keeping the amount of registers we use down is a good thing. So, okay, so our black border worked with only storing X into WSync every time. Let's see if it works with the red. So I'm going to take this, I'm going to put it outside, and I'm going to do the same STX. We're going to store whatever's in X, it doesn't matter, 30 into the WSync. Okay, now we're talking. That means we don't have to use a separate register. So that's cool. All right, so in that case, we want to have, so this actually, obviously this would dramatically decrease the amount of code we would be, writing, because you got to think of every instruction takes up ROM space on these games, in that, or these programs on the Atari, the 6502. I guess anything like this. Basically, every instruction will take up at least a byte. The STX instruction, store X, takes up 1 byte. The address that you're storing it in, it takes up a byte. And so each one of these commands that you're running will take up a byte. And when you consider, and one of the things I find interesting about this is that the limitations are so strong. We only have 4K of ROM space that we can use. 4,000 bytes. So if you think about it, every instruction matters. Every, sperm is sacred. No. Every byte is sacred. And so if we can trim that down to where we don't have as many bytes being used, that's awesome. So these repeats right now are actually taking the code and actually unrolling this to where it is, instead of it in the code when it compiles it, is instead of saying stxwsync one time, it says it 5 times. So it actually copies and pastes 5 times effectively. That's not good because it's going to be using 14 times. So this is going to be storing it 14 times in the code. That's 14 bytes that we could be using somewhere else. So we have to be efficient. We have to say let's not do it that way. These are individual bytes. We can't get around this. We might be able to get around this because the previous frame had 0, but I'm not worried about that right now. And we do need to store it in the background. But we just have to store something in wsync. So what I'm going to do is, instead of this repeat, I am going to say we're going to need another register just to use for looping. And so interestingly enough, I think what I want to do is, because the accumulator doesn't have an increment option, we need an accumulator to be, or we need a way to increment a variable. So what I'm going to do is I'm going to use, instead of the X register, I'm going to use the A register. So I'm going to say we're going to store A, or 0 into A, and use A instead. And let's just verify that it doesn't break anything. I should do Stella kernel, just so it's one line. I'm lazy. Okay, no breaking yet. That's a good sign. So A should work. I'm gonna, just for fun, I'm gonna make sure that this works here too. So I'm gonna make it with our red stripe. Oops, there we go. Our red stripe looks good too. Okay, good to go. So now we can do is we can use X as our variable that we're going to increment. So I'm going to store LDX. I'm going to store 0 as well. Now, one of the things I've noticed is they use # for here. I believe that # is a memory location as opposed to, I think it's a direct, as opposed to a value. I could be wrong. I need to look into that. We're going to store X. We're going to store 0 into X. Fine. And instead of this repeat, which is, as I said, it's actually just copying and pasting the code. What we're going to do is we're going to set an identifier here, a label, actually is a better word. And so we're going to set a label there. We're going to increment X, which increments it by 1. Okay. Then we're going to compare X with a number. I'm really curious if that's, I'm not quite sure. We're going to compare it with 5. That means we're going to do 5 lines, and if branch not equal, black. So basically what that means is it's going to compare whatever is in X with the number 5. I need to confirm on the addressing modes and # versus $ and all that. But the idea is that we're going to be doing this 5 times. So we're comparing whatever's in X, which is currently starting with 0. This makes it 1. And then what we're going to do is we're going to say, compare that with 5. Is it equal 5? No, branch not equal. So basically it goes back up here. And then it does it again. So we're going to keep doing that for 5 times. Once it equals 5, it gets out of this. The branch not equal is how you do the loop, basic looping. So I'm really curious about 6502. versus, let's see if I can do this. Unfortunately, there's symbols that makes it very difficult to search for. Addressing modes. It's a good thing to look at. And it might be something I need to look at. For the 2600, but I don't think so because it's 6502. So this is the $ is definitely a memory location. Uses absolute index. Okay. All right, let's see. 2600 addresses. Let's see if we can find. Yeah, this is probably on the same. Yeah, absolute. Okay. So this is a good example here. Okay, load accumulator with the number 80. So 80 is, when you say dollar, that means that it's a value. And then we're saying load accumulator with contents of memory location 80. Interesting. Okay, so you can't store to a number. So $ means it's a let's see. Load X register with the number 80. Okay, that's normal. Store accumulators contents in memory location 80. It's because, yeah, storing is always a memory location. And loading, so if you load, am I loading? I don't think I'm loading, I'm only storing. Oh no, I'm loading. Okay, so I'm loading 0. Load accumulator with contents of memory location 80. So instead of a value, so that's interesting. Okay, so the issue is that I need to be using this. And the reason why is this will work. This is probably my problem that I had before. I almost guarantee it. Because I'm not using the right values. Okay. That tells me something. Okay, so what that means is that 0, the memory location 0 is something we can access and we can use. But what I actually want to do here is I actually want to, because we don't know what's going to be in 0. Later on, it could be changing. What we actually want to do is we want to store the actual value of 0. So I'm going to make a comment here. Store, yeah, comments are very, very useful in assembly language because otherwise it's so hard to follow otherwise. Store 0 into a register. Maybe I want to use that register. And then store 0 into X register. Okay? So we're going to store whatever's in A to be into the color background. Okay? That's fine. And then we're going to store whatever's in A, which is still 0 at this point, into WSync. Now what we're going to do is we're going to increment 0 to, or X to go to 1. And then we're going to compare it with this. Now, what's interesting is why it's with a pound sign. My thought process there is that it's, yes, that's what it is. $ is going to be hex. I believe that this will work as well. Let me try it. The reason why I think you'd want to use the $ is to say This is the value, and it looks like that's what they're doing here. It's decimal. If otherwise, if it's 0, that means it's going to be in decimal. If it's $0, that means it's in hex. It happens to be the same number. And in this particular case, we want it to be 5 in decimal. When we get down here, we don't want to be using hex, because then we'd have to convert it to hex from decimal, and we get the wrong number and all that fun stuff. So we're not going to worry about that. First of all, let's see if this works. We should, I'm actually, let's see, can I control C? Yeah, I'll control C it. Let's see if this works. Okay, so far so good. We still got black lines, but that's not that interesting. So, man, I'm gonna want to do a subroutine for this, but it's okay. We'll get to that. All right, so we got our black border. Let's rewrite this red stripe as being in a loop instead of the repeat. One of the things that would be nice here is, and DASM probably will tell me, initial code segment doesn't say, okay. References to unknown symbols. Okay, I don't care about those. What would be nice is if it showed me the amount of ROM size that I'm using here. Let's see, right? Okay. Segment name, final RPC. It doesn't tell me. Okay, it'd be nice as if it told me how many bytes I'm actually using. Whatever. All right, so let's do this with red. So I'm going to create red stripe. Okay, actually, I can use that same comment. Someone's in my house. Okay. Now, we're going to store our color that we want in there. So 30 is the color we want. Now, why do we use $30? Because that's, oh yeah. Wait, storing, loading, LDA, we want to store the actual value 30 into our A register. And we also want to store, I need to use a restroom, so I will be back in a minute. Okay, I am back. I just thought, I should probably change the stream name so that maybe other people would find me. Really curious who's in my house. Whatever. So live streaming. Let's see if I can change my name. Can I change it? Yes. Learn. Currently learning how to program the 2600. Is there there's no tags. It doesn't look like. I'm gonna just change that. Okay. Okay. Whatever. Wow. I've been doing this for almost 2 hours. Huh. Okay. Okay. Where was I? Okay, so we're going to do a red stripe. And we're going to do the same color. So we're going to do a red. We don't need that. We need to do that first so that we set the red color. And then we're not going to repeat, or we're going to use our thing here. We're going to say, we're going to store X, we're going to increment X, and we're going to compare that with 14. Now, what would be nice is eventually to not use just a magic variable here, or magic value or whatever, magic number. 14, in programming, typically you don't want to use just a normal number, just bare. But I think it's pretty okay in some of the language. So we want to do a B and E red. Okay. It's less code, or it's the same amount of code, or maybe just a little bit more. But it's a lot more efficient as far as the memory locations go. So I'm going to try, see and make sure our red stripe still works. Interesting. So we got half a stripe. Why? We're comparing with, oh, I know why. Can any of you guys tell me why? What it is that we did not reset the X, the X register. So, because basically X was still sitting at 5. So we're only going to get 9 lines as opposed to 14. So what we need to do here is let's do LDX of 0. We gotta basically reset our counter so that we get the right value. So let's try that now. Back to normal. Yay! Okay. So now I'm going to do the same thing. I'm going to copy and paste this here for the white stripe. And for the white, we use 0E. And we've got the same exact code here. The only difference here is that we have white. Okay. So we're going to do a red stripe, red stripe. Now, this should work. Let's verify that it works. Okay, still working. Cool. Now, here's where things get a little tricky. What I want to do is I want to do an outer loop. And so there's a couple different ways to make this even more efficient. Yeah, because I could do red, white, the same way I'm doing it. And that's cool and all, and it's, somewhat efficient, but it'd be better to make it in an outer loop, because we know we're going to be alternating colors, all except for the bottom. So we're going to do this 1, 2, 3, 4, 5, 6 times. It seems really bad to use, to copy and paste this 5 more times. That seems dumb. So what I want to do is I want to make a loop up here. And we're going to do, I'm going to call it stripe pair. Okay. And what I'm going to do is I'm going to use the Y register. And I'm going to store 0 into the Y register. We're going to use this as an outer loop. Because we got these small loops here that are doing their things. But now what we want to do is after this is done, we're going to want to compare Y with a value. And we said we're going to do 1, 2, 3, 4, 5, 6 times. So I'm going to compare it with 6, the number 6. And then we're going to say branch not equal stripe pair. So what that means is that it's going to use the Y register to loop. And that's what it's there for. So what we're going to do is we're going to do this stripe pair, and we're going to do this 6 times. The thing is, we're still going to need a red stripe. I don't see another way of getting around this of having more code in here. So I'm just going to copy it in here. So this last one is a red stripe. That looks good. So now we're going to do our stripe pairs of, we've got our stripe pair of red and white stripes. So it's going to do this 6 times. And then it's going to do a red stripe at the end. Because we start at red and we end at red. So now all of this other code can go away. We need our black border, and that's cool, but we can get rid of all these. And we've got our new black, our black border here. So let's put this down here. So now we've got it so that it will go, do all the red stripes, the red and white stripes, and then it'll go to black. Let's test it. Okay. Source is not resolvable. Wow, this is interesting. I haven't seen this before. I wonder what I did wrong. Label mismatch, huh? Red, black, red, black. Source is not resolvable. I know why. Okay. I reuse the code. I reuse the names. And it doesn't like that. So instead of black, let's do top. And we're going to say top. There's going to be a better way to do this, and that's going to be when we're dealing with subroutines, but I need to brush up on that on 6502. For now, I'm just going to say bottom, bottom. We could have called it bottom border or something, but it has to be a different name. We can't use the same name as we did up here. And we also have the problem with the red right here. Because we use red up here, we have a problem. So I could call it red 2. I can go red bottom. Bottom is still used for that. I'm going to call it red 2. Why not? That's icky. Red, fine. Red bottom. Red bottom. Okay. So let's try this again. We got something going on. did something wrong. The fact that it's not red and that it's scrolling means usually there's not the right amount. Hello.
Hello.
Just FYI, I'm live streaming, so I am on the internet right now. I don't think anyone's watching, but it's okay.
What are you live streaming?
I'm doing Atari 2600 development.
Exciting. Very exciting.
So what's going on? Why are you here?
Shouldn't you pause that?
No, I can't really easily. Either I stop it or not. What?
Decided to.
Don't you work tomorrow?
Yeah. I mean, I'll be leaving, but
Oh, okay.
I decided to stop by here first. My window was supposed to be fixed yesterday. I still need to text Kaylee to double check, but if that's the case, then I can probably take him back.
He made his internet debut last night.
I heard.
Mom tell you?
Yes. What did they think of him?
I thought it was cool looking, but I thought it was funny. It was just like, you know, it was like, yeah, it's kind of an exotic pet. So
Yeah, it is.
It was huge. He was pretty low energy last night, though.
Yeah.
So, not like yesterday morning when Mom was feeding him. Oh my God, he's like, feed me! I swear he's gonna be thinking he's dying.
Yep, he does that every single morning.
Feed me!
He thinks he's never
Feed me!
even though he definitely is.
Okay, so let's see what we did wrong, or what I did wrong. We have a striped pair that is doing us 14 lines. 14 lines. We are setting X back to 0. So what is the problem? We're storing 30. We're storing 0. Okay. It seems like maybe there's too many lines. Striped pair, we're doing this 6 times. Just out of curiosity, let's see what this does. Gotta compare. Oh! I didn't increment Y. That's why. So it only does it once. So we need to increment Y. That's the problem. I know that's a problem. We'll see if that's the problem though. No. Okay, let's try again then. Striped pair. Oh. No. No. We need to set LDY before going into the loop. Okay. So now, maybe. Yay! Okay. So we now have much less code. And we're now we now have this available. So you know what I think I'm gonna do is let's do some code cleanup, and then I'm gonna pause, I think, because I need to probably eat something. I don't know what a lot of this is. I don't like the fact that it's indented wrongly compared to the rest of the code. So let's just clean up some of the code here. Let's delete this. We need to indent it though. Reset stays. Let's get rid of this. Indent. I like the 2-space indenting. You know, it could be, although one of the things that I don't like is that when you have this here, I'm wondering if it needs to stay on that same line now, to be totally honest. Let's do this. Okay. Start a frame. These guys, let's delete these. And let's get off of that. And then we're gonna do this vsync, vblank, vertical blank. I think I can move this down one line, but I'm gonna make sure that this all works first. Okay, so we're gonna display, okay, this I think can come down one line. And then what we're gonna do is I'm gonna get rid of a lot of this. So we got an overscan here. So I'm gonna actually use the same type of vertical blank thing right here. So instead of vertical blank, I'm gonna use this down here, and I'm gonna say vertical blank. Instead of vertical blank, I'm gonna call it overscan, and I'm gonna call it overscan here, and I'm gonna say B&E vertical blank, so I'm gonna say overscan. And then we can get rid of this, and then jump to start a frame. That's all fine. These guys, I'm not exactly sure what I need them for, but it's a thing. Okay, let's get rid of some of these lines. This looks pretty clean now. Let's see what we got. Okay, so this works still. So let me, just for fun, I'm gonna put this on a separate line. I think that it can be on a separate line. I'm not 100% sure, but I'm pretty sure that is a thing. Yes, we are good. Okay, so I need to do some more research. I did do a little bit of work to figure out how to make a square, but I'm not really worried about that at the moment. To make our blue square, that's going to be the next thing. What I'm thinking of here is that we draw a blue square for the stars area, and then we try drawing stars. Now that should be very interesting, because yeah, that's going to be definitely interesting. We'll see how it goes. All right, guys. I think that's my time for now. Thank you for anyone that joined me, and I am going to put this up on GitHub. So if you want to follow along, if you want to see what I'm doing, I'm going to probably set that up on GitHub. So I will add that before the next live stream, and we'll see how it goes. All right, guys, take care. All right, bye.